Hello class, I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, today I will be discussing durability part 2, where I will be going to discuss corrosion of embedded steel. So, that is the most important topics, because most of the reinforced cement concrete structure or pre-stressed concrete structure losing their life due to corrosion, premature life of the structure. So, we will be discussing this thing in this particular lecture, how corrosion is going to occur and what are the factors which is going to influence the corrosion. So, what is corrosion? I have taken this definition from ASTM, American Society Testing Material G15. Sorry. So, chemical or electrochemical reaction between a material, usually a metal, and its environment that produce a deterioration of the material and its properties. So, that is going to deteriorate their properties, they will lose their strength. So, that is here, if you see here this structure in this plate number 1, due to the corrosion, reinforcement, the area of the reinforcement has reduced, and not only that, if you see there is a spalling of concrete cover also, and some you can observe here some cracking is also going to occur here, and due to this cracking more ingress of deleterious material inside the concrete, which is further going to increase the corrosion. If you see here the inverted plan of the slab, where you can find this reinforcement has completely gone, their area of cross section is almost vanished, and they have given a stain, some color on the concrete also. So, this is the effect of corrosion, and this structure will lose their complete strength, and finally, this structure is going to collapse. So, corrosion cell. So, how corrosion cell is going to generate in reinforced cement concrete structure. So, there is a two way. So, one is when two dissimilar metals, say you have aluminum or steel, exist due to their potential difference. So, that may cause corrosion in the reinforced concrete structure. Secondly, in the vicinity of reinforcing steel, concentration cell may be formed due to difference in the concentration of dissolved ions such as alkalis, chlorides. So, that may initiate the corrosion cell, and those corrosion cell will cause corrosion in the structure. So, how corrosion cell develop? If you see, one place anode will develop. So, here metallic ion get, and another place cathode will develop. So, steel Fe, iron, that will be converted to 2 electrons and Fe2 plus, and if you see the cathode, at cathode we have a half oxygen molecule and plus H2O and 2 electrons. So, that is going to produce 2 hydroxyl ion. So, this hydroxyl ion and this ferrous ion is going to create the compound FeO H2O X. So, this X will be going on increasing. So, this ferrous iron oxide is a rust. So, what will happen? What is the problem with this iron oxide? So, rusting volume is much more higher than the original volume. Generally, it ranges 2 to 6 times, and sometimes more than 6 times also the volume of the rusted material. means iron oxide, you can get this volume is very high. So, that is going to exert the pressure. So, if you see this process here, how this is happening, here see, here is the anode. So, in this in one place, due to the difference here in the same bar, one place cathode will be there, another part anode will develop. So, from here we are getting the ferrous ion ejected here, and from here this current will be getting formed. So, how we are getting here? We have to get the moisture from here. So, ingress of oxygen and moisture is necessary to initiate the reaction. So, cathode process is nothing but oxygen molecule plus water, and this electrons is going to give you the hydroxyl ion. Okay. And similarly, iron will going to eject Fe plus plus and plus 2 electrons. Okay. So, finally, we get the corrosion material here. So, this is the electrochemical process of steel corrosion in moist and permeable concrete. So, this figure has been taken from the very renowned author Mehta and Monetrio, Micro Cracking of Concrete. So, here moist concrete act as a electrolyte. Iron oxide or hydroxide surface film on the steel. So, here you can get the here on this surface you will find the corrosion material will get deposit here. So, this is the process of steel corrosion in moist and permeable concrete. So, if you see, so earlier we have here FeO. So, this reaction will increase, then you will get FeO. Then once again further deposit of corrosion material, this volume will increase here Fe3O4. So, this volume has been taken in centimeter cube, and here you can say here once again volume has increased to Fe2O3, then FeOH whole twice, FeOH thrice, FeOH thrice plus 3H2O. So, you can find the volume of corrosion. So, this is the rust, volume of rust, volume of rust. So, what this volume of rust is doing here? Because steel is embedded inside the concrete. So, suppose you have a concrete surface here, say let us say we have a steel bar here. What we have? A steel bar. This is the original condition. So, this area say this area is going to reduce, actual original area is going to reduce, and say this is your, let us say this is your concrete surface, this is your concrete. I have taken the cross section here. So, you can say this is the original concrete structure. This is the original concrete structure. So, say first it is going to form the FeO. So, FeO, what will happen? This is going to put certain, this is going to put certain volume here, this is going to put certain volume here, certain volume. I will take some different color, so that you can visualize the things in better way. Okay. So, this is the corrosion material here you are getting first. Secondly, once again volume has increased, then it has been getting from another material. So, this is going to deposit here. So, till that what will happen, because volume has not changed more. So, due to as a volume has, but still it is under stress condition. So, what is happening, this concrete is getting stressed, and we know concrete is very poor in taking the tensile strength. Okay. So, as the pressure increased here, this is under high pressure. Once again another compound Fe2O3 is going to deposit here. So, once again this stress going on rising. So, further when their tensile capacity is not capable of taking the stress, then what will happen? Some cracks will start appearing on this surface, appearing here inside. Okay. So, then further formation of FeOH2 will lead to this increase in volume and increase in this pressure, and finally, what will some cracks will start forming and it may come up to the surface. So, how this corrosion is going to occur? What is the main important phenomena? So, you need some material, say you need oxygen, you need a moisture, water, yeah, and sometimes you need a chloride also. So, this agent will find more access to this concrete surface. Okay. So, more moisture will start going from here, more oxygen will have a supply here, more chloride have a supply here, and what rate of corrosion will increase. What will happen? Rate of corrosion will increase. So, initially whatever the rate was there and further stage their rate will increase, means suppose your structure has shown the sign of cracks say after 10 years. So, you do not think further crack is going to take less time, it will increase further, and finally, what will happen within another 3 to 4 years complete structure may not be fit for use, it may collapse also. Okay. So, this is the things what we have observed. So, because concrete by nature it is a permeable. So, there is a once you do not have very good quality of concrete, what will happen? Rate of ingress of rate of diffusion of material like carbon dioxide or chloride or oxygen or sulphate will going to inside the concrete structure. So, due to ingress further it will increase and this will lead to the complete crack of the structure. Okay. So, this is the phenomena you can observe. So, by observation you can analyze what is the cause of corrosion. Okay. So, factors affecting corrosion. So, there are different factors which is going to affect the rate of corrosion like pH value of concrete, carbonation of concrete, reaction with chloride, moisture present in the concrete and ingress from the outside, oxygen, ambient temperature and relative humidity, severity of exposure conditions, quality of concrete, cover to reinforcement, initial curing condition, formation of cracks, high carbon content in the reinforcement, inadequate grouting of pre-stressed concrete, contact with other metals, alkali aggregate reaction, formation of antagites, cracks in a structure, all these things affect the corrosion in the structure. So, out of this I am going to discuss some few in details how it is going to affect the structure. So, here we have a pH value of concrete. So, what is the pH? How we get the pH in concrete? So, pH, because in cement concrete we have a two important compound C3S and C2S, tricalcium silicate and dicalcium silicate. This react with H2O, this react with H2O, and that they are going to make two compound calcium silicate hydrase plus calcium hydroxide CH, CSH plus CH, and perhaps this is having a exothermic reaction. So, there will be always generation of heat. So, this calcium hydroxide present in the concrete due to the reaction with C2S and C3S. Okay. So, this is going to increase the pH of the concrete. So, pH is alkaline, concrete is alkaline in nature, and generally their value is around 13. So, once concrete is having the value above 12.5, that stage is considered as passive condition. Passive condition. So, in passive condition, pH value is greater than 12.5. So, once it is having a 12.5 pH value, corrosion will not initiate. Okay. And once this value will go down due to some reason like carbonation or initial condition of the concrete, that depends on the types of cement also, amount of cement also. So, this pH value, if it is going down, then it will become active, that will become prone to condition, prone to corrosion. So, passive means it will go down, down means it may go to 8, 9 like that. Okay. So, you should have sufficient amount of cement, minimum amount of cement is restricted by IS code, depends on the exposure condition. So, if your exposure condition, we have defined 5 exposure conditions which we have discussed in previous class, like mild exposure condition, moderate exposure condition, severe condition, very severe condition, extreme condition. So, depends on that they have restricted that you must have minimum of this amount of cement, so that pH of the concrete be higher than 12.5. Further, there is a carbonation process. What we have? There is a carbonation. So, what will happen in carbonation? We have calcium hydroxide in concrete. Okay, this is the parent in concrete. So, this is going to take carbon dioxide from the atmosphere, and this will make a CaCO3. This is going to make a CaCO3. So, what will happen to this CaCO3? This CaCO3, this is nothing but limestone. Okay. So, their pH is going down because you are just consuming this calcium hydroxide. So, once this carbonation is going to take, and this is going to make the calcium carbonate CaCO3, then what will happen? This concrete, suppose you have this surface, we have a concrete here, okay. This is having concrete here, and say this is the reinforcement we have here. Say we have a reinforcement over here. So, this reinforcement is protected, it is in passive condition because pH is greater than say 12.5. So, as this carbon dioxide is going to ingress from this part, which is a rate of diffusion is very, very slow, it is not so fast. Okay. So, in a year it may depends on the concentration of carbon dioxide in the environment, it may range between 0.1 mm, it may go to 1 mm also, depends on the carbon dioxide concentration. Okay. So, as this will be going on increasing, so this passivity is going to reduce, it will convert into active condition. Okay. So, finally, this is no more protected against corrosion, and this corrosion will take place. So, carbonation test we do by phenolphthalein, just we spray the phenolphthalein indicator, and if it will become colorless, say this part has become colorless. So, this depth up to which we have lost the calcium hydroxide, which has been converted into calcium carbonate, is called depth, carbonation depth. This is called carbonation depth. Okay. So, this is the thing we have discussed. So, similarly, we have discussed pH value, carbonation occur, reaction with chloride, that is also very, very important, because if you see the this phenomena of chloride, how it is going to react with the chloride. This is the chemical and electrochemical condition has been shown here. So, this will create a galvanic shell, and this will break the passive field, and you have a very concentrated type of pitting corrosion. Means most of the places your reinforcement bar will be in a good condition, and but as this portion has gone here, suppose you have put certain salt here, okay, or urea you have put here. So, what will happen? This is going to have a pitting effect, and area of reinforcement will get reduced. So, as the cross section will reduce, strength of the structure will reduce, and finally, this structure will collapse, either if even it is a pre-stressed concrete structure, if tendon or cable area cross sectional area will reduce. So, wire will get snapped, and finally, complete structure may collapse. So, we have to see that there should be no penetration of chloride inside the concrete. Sorry. Okay. So, sorry. Okay. So, here we have seen up to the reaction with chloride, then we have a moisture. So, starting the corrosion, moisture is very important. If you do not have a supply of moisture, then corrosion will not start. Similarly, oxygen. So, oxygen and moisture is very important. So, that is important parameter, moisture and oxygen. Moisture and oxygen. Here moisture and oxygen. So, this also going to affect if your concrete is exposed, your permeability, if your permeability of concrete is more. So, there will be more ingress of moisture and oxygen, and rate of corrosion will be faster. Similarly, we have ambient temperature and relative humidity. So, if temperature is high and humidity is above 50%. So, there will be more chances of more rate of increase of reaction with moisture and oxygen, and finally, we will get rate of corrosion will be faster. Another is severity of exposure conditions. So, we have 5 exposure conditions like mild, moderate, severe, very severe, extreme. So, if it is your concrete in extreme condition, their chances of corrosion is more. So, what we have to do? We have to consider the quality of concrete. So, quality of concrete is also very important. So, if your quality of concrete is good, means you have compacted this properly, you have placed it properly, water cement ratio is less. So, in that case what will happen? Ingress of deleterious material which is causing the corrosion will be very slow. So, rate of corrosion will be less. So, like permeability is very important phenomena. So, if by nature concrete is permeable. So, you should not have interconnected capillary, otherwise ingress of oxygen, carbon dioxide, chloride, moisture will be faster, and corrosion rate will increase. So, quality of concrete is equally very important. Okay. So, we should have a best quality of concrete. Then we have Covert reinforcement. So, Covert reinforcement is important, and IS code depends on the exposure conditions. They have given different cover depth of the cover for different type of structure. Suppose it is in mild exposure condition. So, minimum cover should be 20 mm. Okay. Similarly, it is a extreme condition. So, in extreme condition we should have at least 75 mm cover, say like if soil is not good, aggressive soil is there. So, in that case you can give 75 mm cover to the foundation minimum cover. Then we have initial curing conditions. So, what is initial curing condition? So, if the concrete has been cured properly at initial stage, so permeability we will have improved. Permeability means concrete will be impervious in nature. So, in that case ingress of moisture, oxygen, chloride, carbon dioxide, all these agent will be very slow. So, suppose you have a concrete here, okay, column is, let us say column, and say here reinforcement, you have the reinforcement and this member is like this, and we have concreted this part here, but you have not done initial curing properly. So, what will happen? You will get a porous concrete here, porous concrete in the cover. Cover will be porous, hard may be very good quality of concrete. So, what will happen? There will be ingress of carbon dioxide. So, that is going to reduce your pH value by reacting with the calcium hydroxide present in the column, which is responsible for making the concrete alkaline. So, alkalinity will go, and as it will become neutral. So, passivity of this reinforcement will not remain. So, that will become prone to corrosion. So, initial curing condition is very important. Then formation of cracks. So, if there is a cracks in the structure here, if there is a cracks here, let us say there is a cracks in the structure. So, through these cracks what will happen? Ingress of say oxygen, water, okay, carbon dioxide, chloride, sulphate, etc. will be more. Okay. So, what will happen? These cracks will further rate of corrosion will increase, and as the corrosion will increase, their volume will increase, and cracks will once again increase. Size of the crack, width of the crack will increase, and as the width of crack increase, there will be more ingress of these harmful ingredients inside the concrete. Okay. So, formation of cracks is also important. So, like you have alkali aggregate reaction, okay. There is a formation of anthracite. So, what will do that? That is also going to increase the cracks. So, through that cracks there will be ingress of water, I mean moisture, carbon dioxide, oxygen. So, those is going to increase your rate of corrosion. So, similarly, if you have high carbon content in the reinforcement, so that is also prone to more corrosion, because there will be potential differences at different places. So, these are the things. Another important thing is inadequate grouting of pre-stress concrete contact with other metals. So, this is also important. So, what will happen if you are not going to grout the pre-stress tendon in post tensioning operation, your tendon may be exposed to atmosphere, and corrosion will be there. So, if corrosion will take place in the reinforcement in the pre-stress tendon, cable or wire, that will snap. So, once it will snap, then your complete structure will collapse. So, similarly, if you see here if you see the I have discussed earlier about the Mandoi bridge. So, they have used chloride, as a admixture for accelerated setting. So, in due course of time, in about 10 years, that caused pitting effect, and finally, that bridge collapsed. That Mandoi bridge collapsed in running condition in 1986, and many people died in that accident. So, that was a very small mistakes. So, corrosion is very important portion. If you see, the most of the structure is failing due to the corrosion, and key thing, you have to maintain a proper quality of the concrete at each and every stage. So, if you have maintained the concrete quality at different processes, certainly you are going to get the good concrete. If good concrete is there, corrosion will be less, and if corrosion is less, then you are going to save huge amount of money of your country. So, we have to protect the economy, because we find here that within 10 to 15 years, most of the building or important structures showing the cracks, sign of cracks. So, that we have to prevent, means we have to use a good quality of concrete, strict supervision. So, okay, thank you.